Hi, everybody. Thanks for joining our demystifying math tricks today. Like you can see on the screen, and then if you're just joining, click the link in the chat. We're going to come back to this Jamboard, but it looks like we've got lots of people adding their ideas, and you'll have a little bit of time later if you didn't get a second to do that. So stay tuned. We will revisit our Jamboard. Just a little bit of an introduction to me and why I'm here today discussing this topic with you. My name is Elizabeth Byrie. I'm a senior ESM of events for the state of Massachusetts. So I work alongside Jasmine in the Commonwealth. But prior to joining Mind, I was a classroom teacher like many of you, and I was intrigued by the idea of inquiry-based lessons, right? And really hands-on learning and having these engaging student discourse moments, right? And so you can see in the picture, the kids are having a great time. They're using manipulatives. They're coming up with their own strategies and their own learning for math. And so I would spend a day or two trying to get students to grasp math and make all these great connections and these discoveries and inquiries. But inevitably, I would get a little impatient because I needed them to pass a test at the end of the day, right? We were a turnaround district, and so we had a lot of pressure to get kids to pass the test, like I'm sure some of you have. So I needed them to be able to figure out this strategy, right? And so in order for them to do that, I would inevitably switch over to some kind of math trick. Like, for example, keep, change, flip. Use your reaction button or go to the chat, raise your hand. How many of you have ever used a trick, perhaps like keep, change, flip at some point? Yeah, keep, change, flip. So again, all of the inquiry and all of the engagement and the really ownership of the learning that students were doing the first 2 days I would introduce a lesson, those were inevitably all undone because they would be like, well, here, use this trick and let's do a page full of problems, right? So that was my bad as a teacher. And it wasn't until I read this book called Nix the Tricks. I got a copy of it here. I'll give you a hint. If you Google it, there is a free PDF version online somehow. But Nix the Tricks is a great short read, very quick. It's an easy read, but it really opened my eyes. And the book starts with a quote, and you don't have to read this whole thing, but just take a look at the blue for a second. On a PISA test, the students with the lowest achievement worldwide, so not just in the United States, worldwide, were students who used a memorization strategy, like a trick, like keep, change, flip. So guilty as charged right here. But what really struck me is students that were the highest achievers were ones who thought of math as a series of connected big ideas. Let me just say that again. Students using a memorization trick or strategy didn't do as well as kids that had these really engaging, connected ideas about math, right? This was huge to me. So I was onto something when I was doing these inquiry ideas, right? But again, I would grow impatient. I would teach them a trick so that they would pass a test. And then I read this quote and I was like, what I'm doing isn't actually working anyways. So how can I get students to make these connections in these really engaging ways, but do it in a more timely manner? So I wasn't spending weeks upon weeks upon weeks trying to get them to grasp an idea, right? My school was using this program called ST Math, and I wasn't really engaged with the program the way I should have been. It was a station rotation, and students were doing some work on it. They were using some tools, but inevitably I never followed up with them. So I thought, maybe I should investigate this ST Math. Let's see what it's all about. Maybe this will help me. And when I logged on, like many of you, you probably have noticed that there's no tricks, there's no text, there's only visuals. And remember, I was just teaching keep, change, flip, this strategy for dividing fractions and remembering the reciprocal. So I went to this game called Elephants and Peanuts, or Peanuts and Elephants. Does anybody play this game? Give me a reaction. Yeah, some of my upper elementary friends, middle schoolers. Yeah, you've definitely seen this game. And this was my moment of, I have no idea what the heck is going on. So I had to have this inquiry, engaging, impactful moment with the math. And once I got it, I was like, oh, shoot, this is why we keep change flip. This is the reciprocal. This is why we need it. I don't need this keep change flip strategy. I need this game. And that was really my eye-opening moment of, wait, you can teach with inquiry. You can teach with visuals. You don't need tricks. Students can not only understand the math, connect it, apply it, retain it, and then apply it to a standardized test, right? So this was huge for me, and that's what brings me with you today. I want to go over some of these commonly used tricks. I want to give you a chance to express some tricks that maybe you've used in the past. And then I want to debunk these one by one. And I want to give you kind of a strategy to start debunking with either your own classroom practices, or maybe you're a coach or at a district level, and you want to start debunking some of these math tricks with your teachers as well. So give me a reaction if you've ever used the alligator eats the bigger number. Anybody ever said this to a student, or maybe heard it said to a student? Yeah, seeing some private chats, seeing some reactions. Yeah, alligator eats the bigger number. I start with this one because it's a big one, probably from very early elementary all the way up through, I taught 5th, 6th, 7th, and 8th grade, all the way through those upper elementary, middle school grades. My students were always, the alligator eats the bigger number. Wait, which way does the mouth go? The alligator, like, they still got this confusion, even though they had this trick, right? Okay, so we're familiar with this trick. The way the alligator's mouth eats goes is the number he's going to eat. But if we really, not only is this completely untrue, like, think about an alligator is going to eat the number 8, and then it's going to eat the number 3, and then it's probably going to turn around and eat you too. So an alligator really is not that picky. It's going to eat anything. How can we actually debunk? How can we get rid of this trick and teach the math behind it? So let's think about this. The strategy we're going to use is kind of 2 parts here. First, let's think about the alligator eating the bigger number. Whether you're teaching kindergarten math or 8th grade math, what are we actually trying to get students to understand? What's the math concept that we're trying to get students to understand? Go ahead and type in the chat, unmute. You can private chat me if you're a little bashful. What are we trying to get students to understand with this? Comparison, what number is greater than less than, okay? Greater or less than, comparing numbers, which number is the greater value? Yeah, we're really trying to understand quantity of numbers, right? That's kind of what we're all getting at here. We need to understand what an 8 is and have that conceptual understanding of what an 8 is. We need to conceptually understand what a 3 is in this case. And then we need to be able to have some kind of strategy to understand which one's bigger. Plus, then we've got this pesky thing about these symbols that students never can seem to keep straight. Well, I'm here to tell you those symbols are not just arbitrary things that mathematicians came up with hundreds of years ago. We're going to go into this in a second. So that's the first thing of debunking math tricks. Dig deep and think, what's the math concept I need my students to learn? Okay, so check mark, we've done that. And then go to a visual approach. And those of us that have ST math, this is your one-stop shop for visual learning. So in the chat, I'm going to drop a link to a direct game. And I want you to play this game for a little bit. And while you're playing this game, I want you to think, what does teaching this skill visually look like? Remember, we're trying to get students to understand quantity. We're trying to figure out where the heck these weird symbols come from. Okay, let's see what that looks like visually. So in the chat, I'm dropping this link. Let's say it's 2:35 right now. Let's come back together in about 5 minutes. Let's see what you do with the visual nature of this game. And again, we're going to come back together and talk about what was your experience visually of this skill. Thanks, like you saw in the chat, if you're having trouble accessing this game, yep, I see somebody's asking me to drop the link again. Of course, if you're having trouble with the link, just let Jasmine or I know. And as you're playing, really have that connected moment of, we decided we're trying to understand quantity, comparing quantities, what this symbol, where it comes from. How is this ST math game helping us with that concept? Come back together in about 4 more minutes. Just got to chat. If you get to the end of the game and it stops, that's where I want you to think about the question. What does teaching this skill visually actually look like? And if you need to play the game, just reload the link. Take 1 more minute, and as you're coming back together, either head to the chat or unmute. You can private chat me. What was your experience? What does teaching this idea of comparing quantities, greater than, less than, did you figure out where this symbol comes from this game? What does teaching the skill visually look like? Mandy says it gives visual representation to the math symbol so they understand the meaning of the symbols. Yeah, let's look at that in a second. And then anybody else notice anything visually? How did this help us? How is this more powerful than the actual math trick? Yeah, I love this game because multiple answers could be correct. We're not just understanding a trick that works for one number compared to another number. We're actually developing this conceptual understanding of exactly what you said, quantity, greater than, less than. Yeah, that's huge. Okay, so let's come back together. Let's take a look at this game just for a quick debrief. So this is the game you were playing, going back to some things that Mandy, Maribel, I've got a couple private chats that said something similar. Let's see how, if you didn't catch on, how did you see this? Okay, let's see. So in this case, maybe you, like me, the first time you saw this game, you're like, but I don't know what to do. I see this line, this piece of uncooked spaghetti moving. Like, what the heck do we do here? I don't know. I'm just going to try something. Okay, so I like the number 8. Let's just try 8 and see what happens. And like you probably know, if you double click on the screen, it'll pause it. If you click again, you can watch Gigi, and Gigi falls into a wall. Poor Gigi, can't go anywhere. Okay, so that didn't work. Oh, I noticed there's this little kind of symbol thing at the start of my piece of spaghetti. Maybe that looks like an arrow, and I need to make it go in the direction the arrow goes. And like Maribel said, there's multiple answers here. So that doesn't make the arrow go down, but that does. But so does choosing 2, but so does choosing 1. So does choosing nothing. Okay, this is cool. So which one's the right answer? I don't know. Let's just pick one and see what happens. Let's pick 2. I bet some of you picked 3. I bet some of you picked 1. Let's see what happens. Okay, Gigi can go down. And then the symbol comes up. Let me show that again. And then the symbol comes up. Oops, I just picked the wrong one. My bad. And like Kathy said, the board mimics the symbol. Let's look at that for a second. I want to go back. So puzzle number 1, we chose a 2. I hear a lot about the board mimics the symbol. Let's see what that actually means here. This was an aha moment for me the first time I saw it. So let's look at this kind of board piece of spaghetti, ruler, whatever we're calling this kind of tool right here. We've got a 4 over here because I can count 4 blocks. We've got a 2 over here. This is showing me that, okay, it looks like 4 is something to 2, but we don't know what these symbols mean yet. But let's do that. Let's go from the top of the 4 to the top of the 2. And then go from the bottom of both these numbers. And this might sound kind of trivial, but it works for almost all numbers. And then connect them. And what do you notice? Yeah, this is where Kathy's noticing. This is where Mandy noticed. This looks like a less than symbol. Okay, so what does that actually mean? Did we get it right? I don't know. Did we get it wrong? I don't know. Let's see what Gigi wants us to do. So again, we've got this symbol. Did that actually get us our answer? Well, yeah, it did, because look what happens. There it is, right? Does this work for greater than? Does this work for equal? Yeah, this is literally where the symbol comes from. So in this case, I noticed this kind of, if I didn't know it was an equal sign, this thing in the middle, it looks like it wants us to make a straight line. Gigi has to go straight across, right? Again, going back to the idea of comparing quantity, 4 and 4, we know that those are the same, okay? Again, if we want to see where this symbol comes from, again, it's not just an arbitrary symbol. It's not just something that, I don't know, Euclid or someone a really long time ago that nobody remembers anymore came from. This is literally, we go from the top to the top. We go from the bottom to the bottom. Oh, look, you may notice there's an equal sign. Yeah, this is literally where the symbol comes from. It comes from this less than, greater than, equal to. It comes from comparing quantity. And you can do this, my 4th grade, my 5th grade teachers, if you're like me, maybe you taught fractions or started to teach fractions with fraction tiles, right? Instead of comparing your fractions horizontal, just turn them vertical. And then this exact same idea about symbol works that way. Maybe you taught using decimal tiles. Again, stack them vertically and you can still get the less than, greater than, equal to symbol using your less than, greater than, or using your tiles. So again, this works with whole numbers like we're doing today. It also works with fractions. It works with start using your algebra tiles and build your equations or your inequalities. Again, you're going to see the same thing. This is literally where the symbol less than or greater than or equal to comes from. So we don't need a trick anymore. We can use this visual. This is why we're going to nix the alligator eating the bigger number, because it's so easy to get students to understand the symbol when you use it visually. Let's tap into our classroom here. And let's talk about, again, unmute, type in the chat, private chat me. If we know that we don't need this trick anymore, less than, greater than, equal, the alligator eats the bigger number, how can you teach this in your classroom? Yeah, you might want to use ST Math. That's great. But if you want to do some kind of introductory lesson, if you want to do your inquiry lesson, what instructional moves do you need to teach this in this conceptually visual way and nix this trick? Yeah, somebody in the private chat is using my idea of uncooked spaghetti. That's what that board reminds me of. So yeah, you could use uncooked spaghetti. Somebody's saying take 2 rulers and again, go from the slope and then the bottom, and that will make the symbol. I love that. Using models to represent the quantities, the numbers, that's a great idea. Yeah, using dry erase, having students use their Unifix cubes and then just draw it. Yeah, so there's a lot of different ways that you can do this instructionally and never, ever, 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 ever use the word alligator or eating ever again. So that's amazing. Okay, we've mixed one trick and now we've got this strategy, and we're going to use this strategy for one more trick. Give me a shout out. Are there any middle school or maybe upper elementary teachers on the call? Yeah, okay, there's some of us. I'm imagining you have potentially ran into this problem, as I did in 5th grade, where we start to get into this idea of negative numbers or numbers less than 0. And students automatically say, when we talk about subtraction, the bigger number goes on top. Has anybody ever experienced this? Has anybody ever had a student say that? Yes, okay, a lot of us, especially in upper elementary, have. Younger elementary teachers, this is no shade to you. I know you have said it. You have been in survival mode because for example, a kindergartner or 1st grade or even sometimes 2nd grade, this works. Like, this is actually factual for what you need students to accomplish, right? Totally true. But is this mathematically sound? No, totally not mathematically sound. When we get into, for example, on the screen, negative numbers and integers, this no longer becomes true. You get a totally different answer. Even with fractions, it's sometimes hard if students don't have a really visual understanding of fractions. They don't know which one's bigger, so they don't know if they need to flip them around, right? And so this trick doesn't, once you get to some higher levels of math, it doesn't work anymore. And we're really developing this huge misconception that we then have to undo as upper elementary and middle school teachers, and it's really hard. So I hope everybody on this call can hold up their hand and promise to never, ever say the bigger number goes on top again. But don't worry, we're going to go through this strategy to nix this trick together. So first, what math concept are we trying to get students to learn when we say the bigger number goes on top? Again, unmute, type in the chat, private chat me. What math concept are we actually trying to get students to learn when we use this trick? Yep, they're trying to understand the idea of subtraction, that you've got to take one quantity from another quantity. Yep, decomposing numbers, that's awesome. Subtracting with positive integers, yeah. And again, does this strategy work with positive integers? Yes. But again, it's not mathematically sound. So then we have this big misconception that everybody has trouble undoing once they get to the upper grades. Yep, can you take a larger quantity from a smaller number? Okay, awesome, yes. Okay, so how can we make this? We're trying to get this idea of subtraction, and this idea of subtraction means taking one quantity from another quantity. Yeah, okay. So we're trying to get this. Mandy, I don't know if you have your hand up, but if you do, feel free to unmute and just interrupt me. If you don't, I'm going to keep going on. Yes, no, yes, no. I know sometimes I don't even know how to put my hand up and down. Cool. Okay, I'll just keep going. So we've we've understood the math concepts we're trying to get students to learn. Okay, now we need to figure out how we're going to, it's okay, Mandy. Now we're going to figure out how to do this visually. How do we get them to understand? Instead of playing one for sake of time here, because I want to get you some time to debunk your own math trick, I want to play this game together, and fingers crossed that ST Math, yeah, Gigi went to sleep on me. No big deal. We'll get this logged back in about 30 seconds. You can time me. I feel a lot of pressure right now. Maybe I should not have said that. So we're going to find this game. It is a 3rd grade game. Pie Monster, you may be like, wait a minute, I'm in a different grade level, and Pie Monster is in this other grade level as well. Yeah, Pie Monster appears at multiple grade levels. We're going to go into the 3rd grade level. And remember, we're trying to debunk this myth of the bigger number goes on top. And right away, when we look at this Pie Monster puzzle, and I'm actually going to switch to a different puzzle. The one I had loaded looks like this. There we go. How automatically does ST Math debunk this trick? Automatically, can we say the bigger number goes on top? Yeah, no, we can't. Why? Because there's no numbers. You're right. Okay, so automatically ST Math is helping us debunk this myth because right now there are no numbers on the screen. There are no text numbers, right? There are no symbolic numbers. Okay, so right away we can't be like the bigger number goes on top because students are like, wait, time out, there's no numbers. Okay, so let's revisit this idea, the concept we're actually trying to get students to know, which is subtracting one quantity from another. Okay, so how is this going to help us? So talk to me again, unmute, type in the chat, private chat me. What quantities do you see? Let's use that word since that kept coming up. What quantities do you see on the screen? Okay, so we see 5 yellow pies. Somebody says they see 2 pies on the pie monster's back. Okay. Yep, 5 and 2, 2 and 5, depending on how you look at it, right? Okay. So if we're thinking about this idea, yeah, Mike is giving us the verbal nature of the actual equation, right? But let's think about this in terms of subtracting quantities. What do I have to take away from what? Well, I have to have these 5 pies, and I've got to take away some number of pies to get 2. Yep, there's 10 blanks at the bottom. Okay, so it sounds like I've got to end up with 2 pies. So let's say these 2 pies, and that means I need to quantitatively take away 3 pies. Yep, so I need to take away not 4 pies, 3 pies. Again, going back to this idea of subtracting quantity, not bigger number goes on top. From this, let's see what happens. So here's our 3 pies. Again, I'm going to pause here for a second. Again, middle school teachers, I know you're very familiar with your 2-colored counters. Could this be an instructional strategy? Come back to that later. So again, what did we see? From the 5 pies, 3 got taken away. There's the quantity. And we're left with 2, and Pie Monster can get across this, or Gigi can get across the screen. Okay. So again, never in that explanation did I say the bigger number goes on top, because we don't even need that trick anymore. What we actually need is just understanding quantity. Doing it this way helps with any type of number. So maybe we get into inequalities and negative and positive integers in the upper grades. Well, if we bring out these visuals again, and we're talking about quantity and taking one quantity away from another, it doesn't matter if we're working with positive numbers or negative numbers, we're going to be able to visually get an answer. And that's why we don't need this trick. So instructionally, how are we going to get students to do this? Instead of saying the bigger number goes on top, what can we do to get them to understand that subtraction is one quantity being taken away from another quantity? Yep, using 2-colored counters, using unifix cubes. Yeah, and even with unifix cubes, just have 2 different colors, right? 2 different colors, have a quantity. Can we take some? Yes, using money. Money is great, especially because you can have negative balances. Nobody has negative balances, right? Just kidding. You can use actual kids as models. Yes, using like actual humans. Great idea. So there's lots of ways to teach this idea of taking one quantity from another. And maybe in the younger grades, you do show that negative quantities are a potential option. Maybe you pull out a calculator and show them. So again, it's okay to introduce students to the idea of negative numbers. Again, you don't have to go into depth about integers and how to subtract them and how to add them and multiply them and divide them. But again, let them know that it exists, right? Because once they get into the upper grades, they're going to be able to see numbers as quantities and see subtraction as having a quantity and taking another quantity away. So in our last 15 minutes, I want to give you some time, and we're going to revisit our Jamboard. So if you had time to add a math trick that you've potentially used or heard used, looks like kicking into a handstand for fraction reciprocals. Yep, so we've got that kind of along the same lines of keep, change, flip. The alligator eats the bigger number. Yep, we've got a PEMDAS is even a trick at some point. Yep. Dividing, multiplying, subtracting. This is our division rule, right? There's also one about like McDonald's eating cheese, something about cheeseburgers, right? Okay, so we have these tricks. they're there to be a memorization strategy. We know, going back to our Nix the Tricks research, a memorization strategy isn't actually producing results. Making conceptual understanding and connecting it to other mathematical ideas is the way to go. So you have two options in the next, let's say, like 12-ish minutes, and we'll come back and wrap this up. If you want to debunk a math myth, one more together, you can stay in this room and we are going to debunk some rounding. If you want to debunk one of these math myths, or maybe you have a math trick that's really heavy on your heart right now, and you're like, I just don't know how I'm going to teach without this trick. You're having a little bit of let go anxiety, right? Maybe you want to jump into the breakout room that Jasmine is going to open up. And maybe you want to do the same activity, but you want to talk about it with some peers. So again, if that's you, if you want to go into a breakout room, you're going to do the same exact thing we're doing here in the breakout room. And again, Jasmine will share the Jamboard again. The same directions are on the Jamboard. So again, all you're going to do is take a math trick that you've used or you've heard used, or maybe your child has come home and has been using it. I want you to collaborate with your group. If you're in my group, I'm your group, you're going to collaborate with me, and you're going to demystify this math trick using the same kind of step process that we've been using. So first, you're going to name the math trick. Maybe some people in your group haven't heard of it, so explain what that means. Then I want you to start the debunking process. I want you to decide what math concept students are trying to learn. Maybe jump into your ST Math console and find a visual way to teach it instead. And then with that visual nature, go into what's the teaching method that I need? What's the instructional method that I need to be able to do this and nix this trick? So again, you have two options. You can use the Jamboard in the breakout room if you want to talk to some peers. If you want to hang tight with me and talk in my room, you can hang tight and we will talk about rounding tricks. Jasmine's going to open up the breakout room. Actually, she says we can't.
It won't let me.
Just kidding. So new plan, you're all going to stay with rounding. Woo! And then if you want to debunk a math trick, you will have my email at the end of this session, and we can definitely jump on another call if you want to ever demyth or demystify some math tricks, right? So let's talk about rounding for a second. I Googled rounding tricks, and this is just a small portion of the hundreds of hits that came up in terms of rounding rules and rhymes. And again, guilty as charged. I used a lot of rounding rhymes. But how can we do this? Remember, going back to our research from our book, memorization strategies are not producing results. Kids aren't able to remember them, recall them. What's actually promoting retention and application is understanding the math and making connections between one math concept and another. So let's ditch this math trick, no more rounding rules. And instead, let's talk about how we're going to demystify this. So when we talk about rounding, what are we actually trying to get students to understand? What concept are we actually trying to get them to learn? Again, you can type in the chat, unmute, private message me. When we round, what are we trying to get students to understand? What concepts are involved in that? Yeah, there's some level of place value, 100%. What number is the number in question closer to? Perfect, that's exactly it. Number sense, yes. Again, going back to understanding what actually is a number, what actually is quantity. Yep. Okay, so we've got these concepts in mind. We need to find an ST math puzzle or a visual way. When is rounding important? Oh, love that, Eric. When is rounding important? Definitely. Okay, so the good news is I already found a rounding game for you. Not Pie Monster, not which one's greater, but our number funnels. And we're going to start off pretty basic because, again, seeing this visually might be a little tricky to us at first if we've been using tricks, right? So let's look here. We went around to the nearest 10th. Okay, so we've got this number 58. Maybe we have no, again, going back to that idea of what concept are we teaching? Maybe we have no idea. We can't remember place value because we learned a trick for that too last year and we don't remember it. Okay, so we don't know what 10 is. What are we going to do? Okay, look at this visual that ST Math gave us. And again, this has a little more symbol on it than some of our math games, but we see the number 58. It looks like, I can't move 58 up here, but I noticed 58 is really close to 60. Okay, so maybe the tens place is like, I'm looking between 50 and 60. Okay. If my other option is, maybe it's between 8 and 5. Look, that's not even an option on here. So I've got to go with one of these. Going back to what I think somebody in the chat said, what number is closer? Yeah, okay, so 58 looks way closer to 60. Let's see if that works. Okay, that does work. All right, so again, now it's maybe I'm figuring out what place value means. The 10 spot must mean counting by tens. I see that on the number line, 10, 20, 30, 40. Okay, that's the tens spot. Great. Okay, so looking at 44, it's closer to 40. And you may be saying, oh, Elizabeth, this is great. The number line's already drawn for you. Of course they can do this. Well, let's take the same idea. Like, again, when we're talking about inquiry, when we're talking about letting students take ownership, give them some time to either draw their own number lines, give them graph paper, give them dry erase boards. Let's have them draw their own number lines, but don't worry, ST Math will scale up to that, will scaffold up to that. And so here we come with a problem that doesn't have a number line, right? And so this is where, again, you can pull out all of those instructional strategies that you just talked about. We can draw a number line, and let's see what happens when we do that. So round to the nearest 10th, again, because I played 2 other levels of ST Math, I know that means I'm counting by tens, 20s, 30s. I'm talking about my tens place value, right? Okay, so rounding 20 to the nearest tens, that's this digit. It's my tens digit. Here's my number line. Again, maybe I already drew it out. So here's where I can spot check my thought. And I need to figure out where 20 is at. Well, here's 20. 20 is exactly on 20. So I don't need a rounding rule. It's already there, right? Okay, so let's see if this works. Okay, so far so good. Rounding to the nearest 100. We haven't seen 100 before yet. Okay, but I know counting by tens meant my number line looked like 10, 20, 30, 40, 50. So I would predict my hundreds number line would look like 100, 200, 300, 400. So maybe that's what I draw out. That's my prediction, and the hundreds place is there. Okay, so this means I'm probably going to put 911 somewhere over here if I'm visualizing this, or if I'm drawing it out on my number line. So that looks really close to 900, much closer than to 1000. Not even close to 800. Okay, so I'm going to leave it right there and see what happens. And again, you can see with these number lines how we're now visually and able to think about fractions and apply to different not fractions, rounding, and think about rounding and applying to different place values. We're still hitting all of those concepts. The idea of place values somebody mentioned, the idea of comparing quantities that somebody mentioned, the idea of when to round. Okay, so let's talk about that. When do we round? How is this helping us here? Well, the problem is asking us to round. That's when we round. No, like maybe that's when you have your greater discussion of when does it make sense to get the exact answer versus when does it make sense to round, and have students come up with these ideas and then test them. Maybe test them with a number line, maybe test them with real world learning. You have some great opportunities to extend the learning and again, make that math connection and have math be a series of connected ideas. And so I challenge you every time this upcoming school year, you think about turning to a math trick, because maybe you, like me, are super panicked about a standardized test and you've got to get them to know the math really quickly. So let's teach them a cute little phrase. Remember, read the book, or even just read the first few pages because the research is fascinating, but read the book. You don't need a trick. You need these deep connections, these visuals, and this really deep math conceptual understanding. And that's going to get your students to be able to retain math, be able to apply math, and it's going to allow you to nix the tricks. So I'm going to stop there with our last 5 minutes and see what questions you have. Are there any math tricks that you're like, actually, Elizabeth, I have no idea how to nix this trick? Again, you can private chat, you can unmute, you can type in the chat. And if you don't have any questions, Rita.
I do have a question for you.
Yes, hello, how you doing?
Fine, thank you very much. The question is, well, regarding the second trick, you know, the greater number goes on top.
Yep.
I'm thinking of those part whole diagrams that we use. I've confessed I'm guilty of saying, well, the greatest number goes in the, you know, in this case is a whole, but will that work, or how can I undo this trick? Because I'm afraid that if it doesn't work for, I mean, it works at a certain point for subtraction. How do you relate that to these diagrams?
Yeah, this is an awesome question. So he's asking specifically about the idea of part whole. How can we use this strategy to help us understand that, again, like kind of still nix this trick? Thoughts on, I know there were a lot of elementary teachers on the call. Let's hear from you first. So think about your part whole and maybe the lessons or the curriculum that teaches it that way. How can you do that in a way that's not reiterating the idea that the bigger number goes on top? So again, let's go through our thought. What concept are we trying to get them to understand with our part whole and our diagrams? Yep, again, quantity, great. Awesome, okay. So this idea of quantity, let's start with that whole number though, okay? So if we're doing part whole, or if we're doing whole, we're comparing quantity and we're subtracting quantity from quantity, right? Okay, so if we have our whole quantity, is that a positive number? Is that a negative number? Well, in a lot of cases, I think what you're talking about, it's a positive number. So let's just say our whole is 8, right? The part that we're taking away, is that going to leave anything left with 8? Or is it going to take all of 8 away? Is it going to take our entire whole away? And then we have something left. So again, I think you can still understand, even with your tape diagrams, understanding the idea of what is the whole, and is taking a quantity away from that whole going to eliminate the whole quantity? Or is it still going to leave part of it there? And I think that's okay to do that way.